Hey, welcome back to the channel. Today we're going to be covering the intro to LAN, the local area network. So for this video, I'm not going to play this. You can watch this on your own time. Yep, it's right here, still on the learning path. So the different topologies. So first we have the star. Everything is going to be connected to a central point, such as a switch or a hub. This is the most commonly found topology, and I believe it's the most expensive. It says I think it says, yeah, so it is more expensive than other topologies. I hope I'm saying that right, topologies. However, despite added cost, it does provide some significant advantages. This is more scalable in nature, which means it's very easy to add devices as the demand for the network increases. Okay. Unfortunately, the more the network scales, the more maintenance is required to keep the network functional. This increased dependence on maintenance can also make troubleshooting faults much harder. It's prone to failure. Okay, so we have that. I'm just also going to start this just because I think this might go along with this. Okay, so it's the ring. Minimize that for a second. Okay, then we have the bus topology, which is known as a backbone cable. This is similar to a leaf of a tree. The sense that device leaves stem from where the branches are on the cable because all data destined for each device travels along the same cable. Very quickly prone to become slow, and bottlenecked devices within the topology are simultaneously requesting data. So obviously if they're sending data all at the same time, it can get a little crazy. So, with this said, topologies are one of the easier and more cost-efficient topologies. So they are going to be on the cheaper end. And then another disadvantage is that a little redundancy in place in case of failures. So that obviously is not good. Ring topology is exactly what it looks like. I am going to open this back up because this is what followed. I believe this one's just going to, like, if there's a break somewhere, it's going to be hard to send things around. It's going to bottleneck it. So let's see. So all devices are connected to two circles to create a full circle. Data from one to another destination. If one device goes down or a cable is broken, then data will no longer be passed. Exactly. So let's just cut this right here, right? So that just stops the flow of data. So as you can see, no more packets are getting transferred along the network. Now we're looking at bus topology. The bus all devices are connected to a single cable. Send left and right. Destination is reached. So obviously this is the one that, not a lot can be sent at one time. It's getting red. Too much. Yep. Now it's down. So that goes to show the flaws of the bus topology. And moving on to star. Okay, device in the central hub. So everything is sent through that hub in the middle. See if you can break the switch. So we're just gonna hammer this baby down. Okay, there you go. We broke it. All right, so now it's down. Okay, we got that. So where's the switch? So switches. So you have all these different computers hooked up to the switch, which is then hooked up to the router, which is going to the internet. You can kind of see that. So switches are dedicated devices within a network that are designed to aggregate multiple other devices such as computers, printers, and other network capable devices using Ethernet. Okay, and then we're talking about a router. Routing is a label given to the process of data traveling across networks. Okay, so into the questions. We got local area network. What is the verb given to the job? I believe it's just routing. What device is used to centrally connect? This is going to be a switch. Most cost effective. Remember we just talked about this. This is going to be the bus. Is expensive. This is going to be the star. That was one of the first things we talked about. And then this is just going to be this right here. Okay. primer on subnetting. Okay, so this is where it gets a little bit tricky. Basically, I am going to pull up my notes. And where is it at? Here. Of course, it doesn't want to load. But there is a table that I have here. Go. No, let's just load. There's a table right here. And it kind of goes to show that depending on how many hosts, so if it's a /24 network, that's going to be 256. But then you subtract 2 because obviously you have your .0 and you have your .255. So it's going to be the 254. But that's kind of the table that I think is easiest to follow. I got that from the TCM Practical Ethical Hacking course. But to just follow this, what is a technical term for dividing a network up into smaller pieces? So just going to be subnetting. How many bits are in a subnet mask? I believe it is 16 or 32. I'm going to say 32 because I see it right here. Okay. What is the range of a section octet of a subnet mask? For this, this is 0 to 255. Like I said, you got to take off the 2 because you have 0 and 255. What address is used to identify the start of a network? So this is going to be your network, not your, network address. Okay, yeah. And then just identify, all right, so identify, this is going to be your host. Address, I'm leaving device responsible for sending data. So this is going to be your default gateway. Yep. Okay. ARP. So this is tying into your MAC address. So your address resolution protocol is what ARP stands for. So you have all this. So just to answer that, address resolution protocol. What category of ARP packet asks the device whether or not it has been specified, has a specific IP address. So this is going to be your request. What address is used as a physical identifier for a device on a network? It's going to be your MAC address. What address is used as a logical identifier for, this is going to be your IP address. Okay, here's all this information here. Moving on, IP addresses can be assigned either manually, so you can make them static, or they have your DHCP, who is automatically going to decide, hand out these IP addresses for you. So what type of ODH packet is used for a device to retrieve an IP address? So this is going to be your DHCP, I believe, discover. Yes, what type of DHCP packet is it? Device send 1 has been offered, so then DHCP, this will be your request. And then finally, what is the last? So this is going to be your DHCP acknowledge. As you can see this right here. Okay, and then next we're going to be moving on to the OSI model. This is something that's super, super important. Obviously, learning anything about networking, the OSI model is huge, learning each step. and how everything ties in together. So yeah, hope to catch you in the next one. Thanks for watching. Please subscribe, like, and hope to see you in the next one. See ya.